All right, here we go. This is problem number 7 from the Halliday and Resnick textbook. It's worded a little bit awkwardly. I remember I had to read this one a couple times, so let me kind of read through it. We'll see if we can figure out what's going on here. So we've got this little box over here. It's a 2-kilogram box, 2 kilograms. And this is an overhead view, so we're sort of looking down from the ceiling on this thing, okay? And it says that there are 2 forces on it, but we only know one force. We know F1 is 20 newtons, but then there's this other sort of mystery force, and we don't know, sort of what direction it points in or anything. So just write yourself a little note. There's some mystery force, and we don't know what it is. All right? So, and then the way it's worded here, like I say, I think is a little awkward. It says for F1 equals 20 newtons, A equals 12 meters a second squared. And that's misleading because it makes it sound like this force causes this acceleration, and that's not what they're trying to say. What they're trying to tell you is they're giving you the values of these forces, or the values of, sort of your unknown quantities, I guess. So it's saying if the magnitude of force 1 is 20 newtons, and the acceleration of the box is 12 meters a second squared at an angle of 30 degrees, then find the second force, all right? But so I guess the thing that I had to read a couple times, or I guess the thing that I was concerned students would be confused about as I read it, is that I want to make sure you understand this acceleration isn't due to force 1, it's due to all of the forces, right? Because remember, the acceleration of an object is determined by the net force, which is exactly how we're going to start this problem. So check it out. We know that the mass of the box is 2.00 kilograms. We know that the acceleration of the box is 12.0 meters per second squared. That means that our net force on the box is going to be 24.0 newtons at this weird angle, well, not weird angle, at this 30 degrees over here, right? So let's break that up into unit vector notation, okay? So that becomes, if you do the math, if you do the trig, the x component ends up being negative 12. And then the y component ends up being negative 20.785. Let's hang on to some insignificant digits there. So that's our net force. Now, where does that net force come from? Well, we've got 2 forces that contribute to that, namely F1 and F2, right? Well, check it out. We know F1. Oh, dang it, I always forget my hats. So force 1 was 20 newtons in the I direction, right? 20 I plus 0 J newtons, right? And then we're trying to find our missing force. So check it out, force 2, this is the thing we're looking for. Well, let's see, we need F2x in the I direction plus F2y in the J direction. Those have got to add up, right? So if you look at this column, we're just saying, 20 plus what is negative 12. So your F2x has got to be, what, 32? No, sorry, negative 32. And over here, your F2y, 0 plus what is negative 20? Well, negative 20. Okay, and then what were we trying to find? Find the second vector in unit vector notation. Oh, there we go. We've got it, right? Here's our I component. Here's our J component. Shazam. Okay, hope that helped.